Okay, so number one I had in mind to just kind of grab the section heading. So the section heading could either include gravitational force, I'll take that. If they say inclined planes, I'll take that. If they even said gravity, I'll take that. If they say inclines, I would take that. If they said gravitational force and inclined planes, that is a superb answer. But if they had any of that stuff, I'm taking it. Two, the book didn't do you a favor really because they didn't make it blue, bold, underline, anything, but there is a word in here that'll matter, but it would have been hard for maybe you to know that it's the word that mattered, but the word that appeared in this that they did try to describe to you is a thing called a normal force. And so I asked you what a normal force was, and maybe you got that and maybe you didn't, but that was about the only thing in this that was really going to be of value to our year. A normal force is perpendicular to a surface. Perpendicular to a surface. So, not to get too far into the future, but a little bit to explain this, I feel like we need some Newton's law explanation, and some chapter in the future we'll get a big Newton's law explanation. I think you might already know from life a little bit of one of Newton's laws, which is every action is accompanied by an equal and opposite reaction. It could also be said every force is accompanied by an equal and opposite force. So for example, right now, there are two forces acting on me. One of them is acting on every object on Earth. What is a force that acts upon right now every object on Earth? Gravity. Gravity is right now trying to pull me to the center of the Earth. But I do not fall to the center of the Earth. Why do I not fall to the center of the Earth? Because of the floor. The floor is exerting an equal and opposite force on me. Right now, I am pushing down on the floor, and the floor is pushing back up on me. I am, to use a word from a few lessons back that make the quiz, I am in equilibrium. Because those two forces are equal, but opposite. If you have any experience with any kind of firearms, Nerf or otherwise, when you shoot a gun and the bullet goes forward, the gun goes backward. That's called recoil. Those are equal, but opposite. Normal forces are doing that. Right now, the force on the floor pushing up on me is called the normal force. So all that to get around to explaining normal force. Gravity's trying to pull me down. The normal force is pushing me back up. I don't go anywhere because those are equal and opposite forces. But that's our stuff in 1 and 2. Inclines and gravity is what this is about. Normal forces in this lesson and future lessons are just perpendicular to surfaces. And then we dig into our old words. So 3, we have scalars are magnitude only, like distance added algebraically. Vectors, magnitude and direction, like velocity added graphically. Vectors are arrows, head to tail, resultant. The first ones are scalars. They have no direction. The second ones are vectors, do have direction. Independently, concurrent, Newton, Pythagorean theorem, tangent or inverse tangent, do the same way. No, it doesn't matter. Equilibrium, condition for equilibrium, equilibrant. 27, it's the same magnitude as the resultant, but it's in the opposite direction. If they didn't mention resultant, they'd be out at least half of a point for that. Don't mention magnitude, you're out at least half a point for that. But it's the same magnitude the resultant has, but it's in the opposite direction. If they say different direction, they'd be out half a point. It's not just a different direction, it's in the opposite direction. Those are not the same. If I walk this way, and I want to then go in the opposite direction, I have to go back to where I started. If I just go in a different direction, I could go literally anywhere. That's not as specific. So we want to make sure we're saying for the equilibrium, not a different direction, opposite direction. Where am I? 28, is that where I am? Mm-hmm. Okay, so components. 29 is resolution, 30 is we'd like them to be perpendicular to each other. The next time there's a quiz, you'll need to read 513 513 is going to have one new point, and that'll bring our chapter to a conclusion. It's still a 30-point quiz. The difference on the new quiz is that number 1 is out, and there's a new number 1 from 513. Pause video for a moment. Here's how we're looking to do 32, 33, part of the homework, and then the rest of the chapter review and the homework is just kind of a conglomeration of old stuff. We just decided there's one main force acting on every object in the world. Gravity. And gravity would want to pull this box straight down toward the center of the earth. And the force of gravity on an object is called its weight. However, in the real world, gravity cannot pull that box on the incline straight to the center of the earth. Where is the box in reality going to go? Down the slide. There's also then got to be a third thing happening, because we have 3 vectors, 2 of which add up to make the weight. The full weight is trying to go to the center of the earth. Some of the weight is going to slide this block down the hill. What's the rest of the weight doing, do you suppose?
Moving over.
Disagree.
Keeping it on him.
Sort of.
Pulling the hill down.
So here's my inclined plane. Why is that eraser not going anywhere?
It's not steep enough.
There's a slant, why isn't it going? Now it will. Why won't it? But now it will. What's stopping it?
The box. Gravity.
Yeah, what if this were ice? Would it go?
Friction.
Friction is correct. Okay, so there's a force of friction. Which way is friction acting?
Oh.
How does friction take effect? Like,
When the eraser.
here's my box. How is friction acting on this? In which direction?
Down.
Yeah, sort of like into the box, like that, sort of. There's 3 things going on here, sort of all at once. Let me draw this to be about that way, maybe. Okay, so the weight is pulling it down. There's a force that they're going to put a little X as a subscript on it. I don't know why. They're just trying to give it some sort of punctuation. And then there's another force. They're putting an N on it, where the N stands for what word? The normal force. In actuality, in my opinion, I'm going to disagree with their drawing in the book, and I'm going to say that the normal force is actually going that way. Why'd I go this way, not that way? What's the difference?
Because the box isn't going to go through the incline.
Yeah, normal forces are always, what was the wording from the quiz? They're perpendicular to a surface. In my opinion, the normal forces act away from the surface. But these 2 forces, back to my Newton introduction a few minutes ago, these 2 forces are equal but opposite. Okay, so I'm going to say technically that's the normal force, but the book disagrees with me, and I didn't write a book, so who am I to argue? Okay, but there is a force pulling that box into the incline. There is a force that wants to make the box slide down the incline. And strangely enough, both of those forces are caused by gravity. Okay, gravity's a little bit pulling the box in. Gravity's a little bit trying to slide the box down. In reality, gravity goes this way. Here's the actual scenario, is that this thing, I just moved it a little bit over there so we could see it better, is a result of this. That's about the same length probably, plus this. If I could draw better, this plus this, how do we add vectors? Head to tail. If I do this plus this, head to tail, I should basically get that. That's what's going on. The weight lives there. What did we do yesterday when we turned one vector into two?
We made them perpendicular.
That's true, and those are perpendicular. What else did we do yesterday with the homework to make some numbers on those?
So we use sine cosine.
We use sine and cosine. I would just suggest that you memorize that the normal force is always going to be the weight they give you and the cosine of the angle. There's always going to be some kind of angle they give you there. People that haven't been through trig, this is just a variable. It's a Greek variable that's commonly used for angles. It's the Greek letter theta. I don't know why in history the Greek letter theta became the common variable for angle measurements, but it just is. This is like an x or a y or a z. It's just Greek. But the normal force will always be the weight times the cosine of the angle. And this other force that's sliding us down the ramp would have to be the weight times the sine of the angle. So homework question 32 is probably something like, there's a ramp at 20 degrees, the weight of the object is 100 newtons. So how would you figure out the normal force?
We could put the weight cosine.
100 cosine,
Angle.
whatever angle, what did I say?
20.
20. So we go 100 cosine 20. If I asked what force is pulling it down the incline, you would have to punch in 100 sine 20. That's all we're going to need to do. The normal force will always be the cosine component. The down the incline force will always be the sine component. And they'll always just give you the angle and the weight. So I say weight is 60, angle of 28 degrees. What's the force pulling it down the incline?
Sine.
What sine what?
100 sine 20. Did you say different numbers?
Yeah, I said different numbers. So I said the weight of the thing is 60, the incline is made at an angle of 28. What force pulls it down the incline?
60.
60 sine 28. What's the normal force?
60.
60 cosine 28. That's what the new homework, that's all that they're doing. It's the same thing we did yesterday, it's just put into a real life scenario. Question? You can cut that.